welcome to your first ever video lecture for CIS 5, Introduction to Programming with C++. Hopefully by now you've got acquainted with the course, you've read the syllabus, you read through all the policies and procedures, you have a pretty good understanding of what's expected for the course. Now I want to go ahead and actually dive you into some of the content from the Gaddis textbook that we'll be using. If you do not have that book, or maybe you have another C++ book, a lot of the same concepts will apply. I do really like that textbook though, as it provides a very nice and concise flow with the way that this course is structured. So the first thing off I want to do is just kind of tell you guys a little bit about me and just kind of where I come from. That way you kind of know where I'm coming from. I'm mostly on the game programming side of things. That's where a lot of my core strengths lie. So how I actually got into programming myself is I had to take a lot of the courses when I was back in school to satisfy a few prerequisites to deal with logic and so on. I actually wanted to do audio for games. That was something that I really wanted to do. And in doing that, I did audio for film and some other related topics. But I found that programming was something that I very much rather liked, and it stuck around. So I got a chance to work for a lot of cool developers, a lot of other companies' projects that I thoroughly enjoyed. And so a lot of the stuff that I'm going to be showing you is from an application field, from just kind of my own personal experience in conjunction with the textbook. So a lot of the assignments may actually be a little game or entertainment related. I'm going to do my best to try to keep this this subject very light for you and very fun as much as possible. So I'll try to stay away from any of the mundane here. So I'm going to go ahead and explain to you by the end of this course what we're expecting that you come out of this course with. This is the knowledge that is hopefully retained by the end of this course here. We want to form standardized programming habits and conform to structured design, implementation, and logical solutions for C++. We want to make sure that you understand what an algorithm is and why it's so important in computing. We want you to understand and learn what pseudocode is, flowcharts, and the way that we're going about implementing and testing things, and we're going to approach problems to be able to solve them. So we want you to have a very clean and concise method for approaching problems. We're going to apply the principles of logical and programming concepts to develop solutions for gaming, business, scientific, and mathematical problems, and beyond. The courses at Norco College feature a large portfolio of directions that one could go in. There's web programming, there's game programming, there's programming for the more business-oriented and scientific fields, if you'd like, and there's a lot of different branches that you can flow out from here. This really is a very nice gateway class. So I have to ask here, so you want to program, and you know, in this being a very introductory course, I want to make sure that you know right offhand, should you continue above and beyond this course, it really becomes a lifestyle that you will find is very habit forming. It's a completely different way of approaching problems and solving them. It's just with a different tool set. I really like having the ability to exercise a new type of problem solving. It's really nice. I really hope that a lot of you guys continue on above and beyond this course. It's a really awesome field, and I'm excited to have you in the course. To understand how we are going to program for computers, it's essential that we understand how computers work. Now, we're going to take a very relaxed view into this subject here, and that's simply because we don't have enough time, and I don't feel that the information would be that relevant to you going forward. So what we're going to do is going to provide just a very nice snapshot of the overview of a computer. and hopefully you'll understand how these things are working together so that you can program with a clear path of what's actually happening behind the scenes. So the computer has these essential physical components, and you may already know this. Hopefully you know these by now. If not, it may be best if you were to take maybe a little bit more rudimentary course just to get you more familiar with the computer. So the CPU, the central processing unit, we usually refer to this as the brain of the computer. This is the thing that actually will resolve instructions down to a Boolean yes or no. It's going to handle all of our calculations for us, all that sort of thing. Next is main memory, and this is the temporary storing place. This is also referred to as RAM, if you guys have heard that, and I'll get to that in a minute. Then you need a persistent storage device, like a hard drive. That way, because main memory is volatile, so if you were to turn the computer off, anything that would be stored in there is lost. So you need something to persist. And that's where the persisting storage device comes into, usually referred to as a secondary storage device. That's your hard drive, that's your flash drive, anything that can be able to store things persisting if power were lost to that device. Input devices, output devices. Input devices could be your keyboard capturing input. Output devices, your monitor, that's outputting a visual signal to that device so that you can see what's happening inside of the computer via a GUI representation of it. And I apologize too, GUI referring to graphical user interface. So CPU in a little bit more expanded view is the component that's going to really provide all of the core-centric execution behind our programs. So this is the device that's going to fetch instructions from main memory, and it's going to continue on this cycle here. The cycle is fetch, decode, execute, store, and then repeat as long as there are instructions in a queue here. Once it decodes the instructions, it then will process this instruction here, and then execute any commands that it has, store any data that it needs to. This data is stored in RAM. The two most important parts of this CPU, control unit and the arithmetic logic unit. The control unit is going to coordinate all of these actions together. The arithmetic and logic unit is going to provide all of the mathematical operations that need to be done. So if somebody wants to move things around, or if you write a program that asks what's 2 plus 2, the arithmetic logic unit is what's going to perform those mathematical operations to get it to the desired result. Now, memory, which we were saying earlier, is referred to as RAM, which also stands for random access memory, is a volatile storage place. Now, this is something that may be a new concept to some of you, or some of you old hat. But what this means is that it's a temporary storing place. So when the computer is booted, when it is ready for operation, it is able to store things into this component here, and it's crucial and essential. So your operating system will have parts of it stored inside of memory. Inside of that, you may have all of your applications that you're running. If you play a game or something like that, all of the data for that is loaded up into RAM and then accessed from RAM so that instructions can be met quickly. It's really to make this whole process very efficient, because if the CPU had to go all the way to the hard drive, that's very, very slow, and we definitely don't have time to wait for any of that. The lag would be absolutely intense. So this component helps bridge the gap between that. It's a very fast and easy way that we can get instructions for the CPU. At the same time, we're not we're not suffering from any things there. So it's divided into bytes, which are tiny storage locations. 1 byte is 8 bits here for our Windows-based operating system here. And this memory is holding both program data and instructions. Look over to the right here, this chart that I have up here, these are referring to memory addresses here. And this is the data that's stored inside of that memory address. So imagine that the memory is segmented here inside of these blocks. Each one of these addresses will hold a piece of data. Now inside of this here is actually a machine level language. So it's an instruction for the CPU to actually understand and execute. For us, we're going to view this as our data that is for our program. So we won't actually have to see all of this here. The program that we're going to be using will translate all this for us. All we have to focus upon is that each piece of memory here will have an address, and we'll be able to store things inside of that address. So just to kind of expand upon that, on what are all these bits and bytes here that we're talking about, byte is made up of 8 bits, or binary digits, as we were saying. The bits work like switches. It's like an on and off state here. And each one carries a charge here. So if we were to kind of represent this here, we may represent these bytes kind of like similar here to Morse code, where we say that if I have, 3 dashes in a row, that's an O. If I have 1 dot, 1 dash, that's an A. So arranging these binary digits in series of on and off will allow us to represent words, and then from there we can represent other more complex pieces of data. Now, we don't actually have to do any of this. Again, as I was saying, this is all very low level. It's just nice to know how this is working underneath the hood. So again, just to recap here, these are arranged in combinations of 8 to form a byte. And they contain a positive or a negative charge, an on or off position. Moving on here, I know I talked about storage a little bit, and if you've never seen a hard drive, this here is a hard drive without the back cover on there. And this is a very basic representation of how it works here. It kind of works similar to the way we would see like a record player or a compact disc, a CD, where it has this armature assembly here and a little head that reads this platter here. Now this platter has magnetic data encoded around the surface here, and this armature assembly reads that data. It's actually very clever how this works. There's a very, very strong magnet that is placed on the top and bottom of this armature arm that's here. And depending on the charge, will attract it to one side of the magnet or the other. So it kind of uses its own momentum, its own polarity, so to speak, to draw it back and forth. And that's what causes it to move back and forth to read the data. Now it flies back and forth on this here really, really fast. Even though it operates really fast, it's still extremely slow. So it's used to hold the data for long periods of time. The storage size is also measured in bytes here, so we measure everything by bytes. Now, currently, these hold so many bytes that we actually have to measure these in larger units, like megabytes and gigabytes, and now terabytes. And we'll keep going on and on as we keep expanding how large these things can be. The other types of secondary storage that exist would be the solid-state drive. The solid-state drive is very popular nowadays. What it features instead of all of these mechanical components here, it just features very similar devices to memory, meaning RAM. So it's the exact same type of concept, except it's able to store all of this data persistently. USB drives, sure, those will persist even though power is lost to those units. Optical media, such as CDs, DVDs, Blu-rays, etc., those all will be persistent as well. By the way, if you guys ever take any of these apart, these magnets here make the best refrigerator magnets ever. Just a side note. So talking about what is a program. A program is a set of instructions that tell a computer how to perform a task. A set of well-defined instructions to perform a specific task is called an algorithm. So there's that keyword there, algorithm. A CPU can only understand machine language, which is a stream of binary numbers, ones and zeros. On and off switches that we were talking about here are arranged in certain sequences. Programs are written in high-level programming languages that are a lot closer to something a human can read and understand at a glance. So that's the whole thing that we're doing here, is we're taking this low-level language that we really can't see and understand at a glance. It's very difficult. It's something that we don't easily interface with. And what we do from there is we developed a bridge, so to speak, where we as humans can kind of speak in this language that the machine will then understand and translate into something that's more native for itself. That's kind of what we're doing here at the heart of this. And because of that, there's not just one language. Well, we have a series of languages, even way more lengthier than this list here. And those languages do the exact same thing. They take all these high-level concepts that we provide, and then when we run the software to start a compiling process, it then resolves it down into the series of ones and zeros, which is the binary digits. Assembles those into a language that the computer understands, which is the machine-level language, and then it will be able to execute those instructions. So all of these here are doing the exact same thing. It's just there's different ways of going about it, and there's different applications for these too. We're currently looking at the C and C++ language. So in order to start programming, we're in a state now to where we have a toolkit that allows us to write these programs and be able to test them, and we have an entire environment for this. Back in older days, in darker times, we didn't have this freedom and luxury. There was a lot of separated tools. They weren't all integrated together. So you may be programming in Notepad or a very primitive compiler, then, or a text editor, and then you'd have to take it over to get it to link, and there'd be a lot of all these other programs that you would have to go in an assembly line, so to speak. Now we have some really cool software environments that combine all of these tools together, and we don't have to worry about that process. So one of the most popular toolkits that's out there for learning this subject here is Visual Studio. And Visual Studio is a Microsoft product, and it's primarily designed for the Windows operating system. So if you were to try to run this on a Mac, you're going to have to do some extra things. I'm going to try to provide some instructions on how to accommodate that. You also do have the option of using the native Xcode application for Mac users that are out there. For Linux, there's some other stuff as well. So hopefully you're using a Microsoft Windows operating system, preferably XP or above. That's perfectly fine. And the editions that we're going to be using will be from 2010 and up to 2013 currently. If you have a newer edition, that's perfectly fine. There's a new one rolling out here not too shortly. So that's perfectly fine. Any of these additions here will be suitable for this course. So back to the toolkit. The toolkit allows us to build all of our source code, which our source code is all of the code that we're going to be typing. And then from there, we're able to go through the compiling process and turn it into machine level executable code. So in order to kind of figure out how do we start, now that we have the tool, we have the environment, how do we start actually going through and typing a C++ program? So the first thing that we have to do is we have to adhere to the rules of the language. This is referred to as the syntax. From there, the next thing that we'll need to make sure that we at least have some understanding as we go, and these definitions will come to us, over time of just practicing and reading upon the manuals, are the keywords. And these are the reserved words. These words have special meanings inside of C++, and they'll usually, in our specific instance of this compiler here, Visual Studio, these instances will light up. So they'll change colors and they'll signal to us that they are a keyword and that they have a reserved meaning. The only thing that we'll have to watch out is that any of these keywords that mean something to the language will mean that to the language and not an actual word that we are typing. So we need to make sure that the compiler is understanding what our true intention is. The next thing is the identifier and variables. Now, you guys haven't learned this, but there are ways to create data sets that will actually contain different, numbers and things like that. You can create these variables, and these here will be something that you can create inside of C++. There are a few rules to doing that, and I'll define those probably in the next lecture here. So just wanted to put that up on the board, but it's something that we'll continue and expand upon in the next lecture. The next thing is the operators. These perform actions between the data. So you'll usually see the operator go right inside, in between two of these words that will have meaning. And that's kind of like, your addition or multiplication operator. It goes in between one number and another number, and there's an operation that's being performed. Lastly, that I have on my list here is punctuation. This is the thing that just says, I'm done, I am completing this instruction. Punctuation is a little tricky, so it will come to you over time what this actually means and when and where to put the punctuation in your source code. So up here, I have the compilation process here where we're taking source code and then we're changing it down into the machine level language, which is the executable code. And this process here involves a few things I want to make sure that you understand. That is all built into our compiler here. The source code is looking at the preprocessor. And what is the preprocessor? The preprocessor reads the source code and modifies it according to the programmed preprocessor directives. Now, these are usually marked with a hash symbol or a pound, or however you want to declare this here, but it's this hash symbol. And then once the preprocessor is then read, then the compiler reads and modifies the source code here and translates it into this machine language, which is now called object code. And once the object code here is modified, then the next thing that we need to do is store that inside of an object file. And all this is happening automatedly too. So when you're building your program, when you're done typing your program, you click, hey, I want to build this thing here. This is the process that's going on behind the scenes. You don't actually have to go through all of this painstaking task here. So that's really nice. But this is what's going on underneath the hood. The linker combines the object file with the appropriate runtime libraries to create an executable file. That's the final product that we end up with, and that's the thing that will contain the machine level language. Let's kind of look at this a little bit in depth. So up here we have what we've said is the include directive up here, but it has a hash symbol. This up here is your preprocessor. Advance the slide here. And going down the list here, these two slashes that are over here and this signaled in green is actually a comment. And you see this throughout the code here, all this green that's here. And those are actually things that I've left for you guys in this program so that you can actually read my code. And what those are comments. So to do that, we signal that anything written after this symbol that we write, which is actually a combined two forward-leaning slashes. And those forward-leaning slashes are next to the right shift key, which is also the question mark key. Putting two of those together says that the compiler will ignore everything after this here. It's just a comment. So what that means is when I put those symbols in there, everything that lights up green after this here, all the way to the end of the line, however long the line might go, after that point, it is ignored and not actually treated as something that would have meaning inside of this here. And this is just used for notation. There's another way to do this as well, because say, like for this here, I have to put these operators here every single time I want to have a comment. Well, here, if I were to have multiple comments all together, and I was to have a block of these comments here, like a paragraph of these comments, I can actually use a multi-line comment. And that here is a little bit different than the single line comment. This is a / and then an asterisk. The asterisk is the number 8 key on your keyboard. You just have to hold the shift key in order to access it. And then to signal that we are done and that we want to actually end the comment, that will be the reverse of the way that you start it, which is the / asterisk. It will be the asterisk and /. And that will say, compiler, ignore everything between the two comment lines. This is, again, used to notate parts of the program or to actually leave comments in there. The way that you'll be using this in your source code is that I require you to place your name and all of your student information inside of a comment up at the top of the source code. This is so that I can identify that, hey, this is your source code once things are downloaded, and I make sure that I can clearly identify who you are and assign the proper grade. So again, we see that this preprocessor directive here, this include directive, we see this up at the top of the source code, and we see that hash in front of it. Now, a few slides earlier, we had said that the preprocessor is the thing that starts in our code, and that's what's read in, and then we go and then we take all of the instructions from there on out. Once we've included all of this functionality, we'll take all the instructions and we'll convert it down into machine language. And yeah, what's happening here is that if you require extra functionality inside of your program, which we definitely will once we start writing these here, you can include all these pre-written libraries that you can actually borrow the functionality from and then use inside of your program. So whenever we do that, we'll need to, in the preprocessor area up here, we need to use the hash and then include keyword. Now this include here will light up a special color, and that tells the preprocessor to include contents from another file, which is usually a library that written for use in a program here. Later on in the class, we will actually learn how to write some functionality that we'll need to include using this method. For now, we're going to only include things that have been pre-written for us. So the next slide here I have is referring to a namespace and what the concept of that is. And we're going line by line here too. This is the main shell or skeleton of every program that you're practically going to write inside of this class here. So it only makes sense that we kind of step through this shell here and understand what it is going on. And in this specific field that's right below the preprocessor is usually reserved for the namespace. What is a namespace? Well, your first program that you're writing will actually require you to include this here. Otherwise, you would have to consequently other keywords and so on. We don't want to make things complicated and messy. So what this namespace is going to do is it's going to define and organize things for us so that we don't actually have to redefine each piece of functionality that we're going to be using from this library here. So in this case here, we'll need to include this line of code inside of our program, and that's going to work with our first library here, which is IOStream. IOStream is just referring to the input and output stream, and that's because what we're going to actually do is we're going to output visual text to a console window. And for those of you that don't know what a console window is, if some of you were old enough to remember old DOS and some of the earlier iterations of the older Windows operating systems, this window right here, when we build our programs inside of this course here, we're going to allow them to output text to this console window. So that way we can actually see what it is we're doing. And actually see like physical results. So it's not anything, you know, crazy and spectacular cool, like, you know, menus and buttons and all this sort of thing. But the core functionality that we're focusing upon, we'll actually be able to view that and see kind of, you know, a visual representation of that. So that's really cool. So that's what we mean by console stream and so on. Cool. The main function that's next right after the namespace here is kind of a lengthy thing here. What is this? And this is actually a function. Now later on we have an entire topic just dedicated to answering the question, what is a function? And that'll definitely go into a lot more detail there. For now here, we only are concerned with this one function here, which is a requirement with the C++ language here. And what this is the main, hence its name, the main area that the program will start from. So no matter what is written in this program here, the instructions are all pulled from this one function here. So if you had a lot of things outside of main that you have written, but none of that is referenced in main, nothing will happen. So what we actually have to do is we have to define the function, and in order to do that, we have to use some keywords here that are a little foreign to you at the moment, but we're going to kind of decrypt this for you here. So the first thing that's written here is this int, and that lights up blue. So that's a keyword here. Now what this int actually stands for is it's an int. It's an integer. And that's the computer's, or the C++ language's way of representing an integer value. So what is an integer? It's a number that you can use, a whole number that will go in the negative number range all the way to the positive number range, and so on. And I'll talk a little bit more about this here in the next lecture. Now, ultimately, what this is on this function here is it's a data type. So it's a type of data. So it's an integer data type. The next thing that is written here is main, and then you kind of see these braces here. Now, I hate to kind of tell you guys this for now, but a lot of this here will be copy and paste this structure, and a lot of this will start to make sense over time. I need to define what this stuff is, though, so that you at least have some understanding of what it is that you're writing currently. Most of the early lecture is going to focus on you actually writing these statements that are contained within inside of this here, and this is where your functionality is going to go, and your spiral outward to where you're actually then writing different components within inside of main to outside of main, so on. So there's a clear path that's going to occur here, but for right now, I know that a lot of this is probably new and a lot of it is probably foreign, but just hang in there with me just until we can get through this. The main here, this is also too something that the compiler will look for. The language too dictates that we have to have in order for our program to run. So this function here will be specifically called lowercase main. Then what we have is a set of argument parameters here. And these are just open and closed. There's nothing here in between this. So it's just open one, close one. And we'll understand why this is a little bit later. Then we actually build the body of our function here, which we will do with curly braces. Okay, so the curly braces will go opening facing the start of the function body, and it will close here. And kind of think of these as like hamburger buns. And I know it's a weird analogy here, but the hamburger buns will cap everything off, and then all of the stuff is going to be contained within inside of the body of this. So here's where your hamburgers would go, and pickles, and all the sort of thing inside of this this body here. Then you see a little bit later down towards the bottom here, you see this return 0. And this return 0, what this actually is it's the return for the function to end. And we'll dive a little bit deeper into this a little bit later. But for you to know what this is now, is it actually is following our instructions, because we said, hey, this data type is an integer. So when we return this function here, when it ends, we should give it, of this data type here, an integer to resolve to. So we choose to return 0 here. And the reason why we return 0 in this case is it's actually an error code that we're sending it. So we're saying complete successfully. There's no errors, and so to speak. But you could literally return any number from this here. Is that right? No. For this here, we're going to say you will always return 0 from main unless told otherwise. Okay. Oh, next up, we're going to cap this off with punctuation. And punctuation is, for us at this current time, it's the semicolon. So what the semicolon does is it terminates a statement and says, hey, I'm done. This is the end of that, this thought here. Now, the problem with this here is that automatically you should be noticing this. You should see that include IOStream does not have a semicolon on the end of it, but yet namespace has a semicolon here. And I mean, main doesn't have a semicolon on the end of it, but return 0 does. So there's a lot of different places where a semicolon is used and where it is not used. From this template here, anything that you write as a statement is usually going to have a semicolon on the end of it. Just as a heads up, when we start diving into structures and different other pieces of logic, you'll find that the semicolon is used in this sense or not. So it will be something that you will learn over time, where and when to use the semicolon. But for right now, this is everywhere where you will use a semicolon, excluding any statements that you write. This up here is a funny, because every time you guys are going to write these programs, you're going to have these errors, and I'll purposely generate a few errors in the next part here, just so that you can see what these look like. And the errors usually are just simply because you're missing a semicolon, or because you have a semicolon somewhere and it doesn't belong there. So it's definitely, when you're running your program and you can't figure out what the problem is, see this little guy right here in the wrong spot or missing it all, he truly is the best hide and seek champion. Don't be frustrated. It's just something that you're going to go through until you get a little bit more skilled with it. I want to talk to you guys about the first thing that everyone does when they write their first program. And in order to, like I said, we're going to bring up this console window. And what we want to do in this console window is we actually want to print text. So what we want to do is we want to be able to say, we want to be able to say something like, hello world. We want this to print out to the console so that we can actually see it. So how can we do that? Well, we have an object here that we can use, and this is part of the IOStream library. Remember that thing that we had to include IOStream, and then the namespace that we had to use as well, that part that said using namespace. Well, what this all belongs to is this, inside of this here, the cout object, is it belongs to that IOStream library here. And we're able to use this to output things to the console, which is our text. So if we want to type out hello world to the console here, which is everyone's first program, so I'm not taking that away from you guys here. We're going to write a hello world program here in a minute. We have to use this cout object. And the cout here just stands for console output. That's all it stands for. So in order for us to use this here, we have to learn the 4 parts of this here. The 4 parts are the chevron here, the cout keyword itself here, the text that we're going to use inside of this the statement that we want to print to the console here. And then if we want to end the line, so say if we want to put this on another line, we can use ENDL, which is end line. These are the 4 things that we're going to have to use: cout, chevrons, text, then the end line. So what I'm going to do now is I'm going to actually take you guys through creating your first project in Visual Studio, kind of getting acquainted with that, and I'm going to do that in the next video.